All right, IBAISL2. Today we're going to look at a couple of examples of probability, but we're going to look at a slightly different sample space called a tree diagram. Tree diagrams can be extremely useful for certain style of problems or for a lot of probability problems. First up, we're taking a class that has 15 students. 3 of them take art, 6 take biology, of whom 1 studies art. That's an interesting sentence because that means that there's 1 person that studies both biology and art, but then there's 5 people that only study biology. Represent this with a Venn diagram. Well, my brain goes right towards this one right here, that of the 6 biology people, there's only 1 of them that is studying art. So that's going to be the 1 person in the middle. There's 6 people that take biology, but 5 of them are not taking art. And then it says 3 people take art. So because 3 people take art and we already have 1 person taking art here, then this is going to be a 2 outside of 2 people that take art but don't take bio. Now, if I add 2, 1, and 5 together, that's 8, and we're supposed to get 15 students. So that must mean that there are 7 students that are not taking art or bio. Now, if I randomly select a person from the 15 people, there's really 4 different types of people. There's people that take art, people that take biology, people that take both art and biology, and then people that take neither. If we were going to find the probability of each of these types of people, I want to fill this second Venn diagram out with the respective probabilities of each of these things. So really, it's just dividing all those by 15. That just art would be 2 out of 15. Art and bio would be 1 out of 15. Just bio would be 5 out of 15. And then the neither art nor bio would be 7 out of 15. Now, we can take this Venn diagram and turn it into a tree diagram. So the first set of branches on this tree are going to be whether or not the person takes art. So we're going to say that this first branch is A, and then the second branch is A naught. So the first decision is whether or not somebody takes art or somebody doesn't take art. Then of those 2 groups of people, you can have people taking bio or not taking bio. So this will be bio and not bio, or this will be bio and not bio as well. So from this diagram up here, the probability that somebody takes art in general is this whole entire circle. That whole circle is 2 15ths plus 1 15th, which is 3 15ths, and 3 15ths is 1 5th. So the probability of A is 1 over 5. Now, I could add up these numbers here to find the probability of not A, but remember that if the probability of A is 1 out of 5, then it's 4, like the complement is just 1 minus that. So the probability of not A is 4 out of 5. Then the probability of B given that they take art, sorry for all the zooming, we're saying that it's given that they take art, hold on, probability of B given A, so it's given that it's A, but would be 1 out of 3. Yeah, okay, so this is kind of an interesting situation. This branch right here is, you know that they take art, but we need to figure out the probability that they also take bio. So if we know that they take art, there's really only 3 people taking art, and 1 of them is taking bio. So that's going to be 1 out of the 3. So this is probability of B given A is equal to 1 out of 3. Now, the probability that somebody takes art and bio would be this section right here. It would be like this end of the tree diagram where you're going to multiply 1/5 and 1/3 together to get 1/15. Which makes sense because this section right here of somebody taking both art and bio is 1/15. Now, if the probability that they take bio, given that they take art, is 1/3, that the probability of not bio, given that they take art, is the supplement or the complement of that, which is 2/3. So this number and this number should add up to 1, just like this number and this number add up to 1. Now to find this end of this tree branch right here, for that path, it's going to be 1/5 times 2/3, which is 2/15. Now 2/15 matches up with this section right here. Those are the people taking art but not taking bio, which is what this branch represents. Art, not bio. Now, for somebody not taking art, whether or not they take bio, well, if they didn't take art, let me get my original highlighter back. If they don't take art, there's 12 people that aren't taking art. And of the people that take bio, it's 5 out of the 12. So the probability of taking bio given not art is 5/12. And then the probability of not bio given not art is 7/12. So the end of this branch will be 4/5 times 5/12, which I believe is 1/3, because you get 20 over 60. Yeah, that's 1/3. Then this branch is going to be 4/5 times 7/12, which reduces down to 7/15. Yeah, 7/15. Now, you guys, these four numbers that we came up with for the four situations, 1/15, 2/15, 1/3, 7/15, those are the same numbers from up here. They're the 1/15 is the taking art and bio. 2/15 is taking art but not taking bio. 5/15, which is the same thing as 1/3, it's just not reduced, is the not taking art but also taking bio. And then taking neither of the courses is 7/15. Look, they all match up. All right. A box in an electronics store contains 9-volt batteries of all different colors. There are 5 red, 6 blue, and 7 orange. Excuse me. 2 batteries are chosen to power up the radio that requires 2 batteries. Find the probability that both batteries are different colors. Well, the first thing we're going to do is represent this with a tree diagram. So picture that you're grabbing your first battery. Of the first battery, there could be red, blue, or orange. So the first part of our tree will have 3 branches. This one will be red, this one will be blue, this one will be orange. Now, the probability of getting red, let's see that there's 5, 6, and 7. If you add 5, 6, and 7 together, I believe you get 18. Is that right? Yeah. And then 5 of them are red. So the probability of this branch right here is 5/18. Then there's 6 blue, which should be 6/18. And then there's 7 orange, so this is 7/18. But then you reach in for a second battery. So we have another selection of 3 different batteries here, 3 different batteries here, and 3 different batteries here. Where this is red, blue, orange, red, blue, orange, red, blue, orange. Now, with this problem, they don't mention anything about replacing the batteries and grabbing like a fresh one. Like you're literally grabbing one of the 18, and then when you go to grab your second battery, there's only 17 left in there. So if it doesn't say otherwise, you can assume non-replacement. Which means that for our branches here, like if I take a red on my first one, the probability of getting a red on my second one, I've already taken a red on the first one. So this is sort of dependent probability. So if I've already selected one red, there's only going to be 4 out of 17 left of reds there. Then for blues, if I've already selected a red, there's still 6 blue in there, but there's 17 total. So this will be 6 out of 17, and this will be 7 out of 17. For this path, I've already chosen a blue, so there's 1 blue gone. That drops the total down to 17, but then there would be 5 reds left. The blues would decrease by 1, so this would be 5 out of 17. And then the oranges would still have 7, so this would be 7 out of 17. Then, on this final branch here, we've selected an orange, so there would still be 5/17 for the reds, and then for the blues, there's still 6, so this would be 6 out of 17. But we did take an orange out, so this will be 6 out of 17 here as well. So each of these ends here, like this spot, you would multiply these two numbers together to get that spot. So that's the probability of drawing a red and then another red. So red and then another red would be 5/18 times 4/17, etc. Each of these branches, like if I go here, then here, this branch would be 5/18 times 6/17, etc. We can keep going to find all these. Now, I'm not going to find every single one because we're trying to answer a certain question with this problem, which is find the probability that both batteries are different colors. I'm going to show you guys 2 different ways to do this. The first way would be finding all the scenarios where you select 2 different colors and adding together all their probabilities. So the ways that you get 2 different colors are like red, blue, red, orange, blue, red, blue, orange, orange, red, orange, blue. So here, I'll color coordinate. I'll do that in blue. So this is going to be the probability of red, blue, or red, orange, or blue, red, or blue, orange, or orange, red, or orange, blue. So, red, blue is the first one, which is 5/18 times 6/17. And then we're going to have to add red, orange, which is 5/18 times 7/17. Plus blue, red, which is 6/18 times 5/17. Plus blue, orange, which is 6/18, 7/17. We're gonna have to continue down on the next line. What did I just do? Blue, orange. Now I need orange, red, and orange, blue. So this will be plus, sorry, what did I just say? Orange, red, 7/18, 5/17, plus orange, blue, which is 7/18 times 6/17. So when you multiply all of that together which I would just definitely grab a calculator for, you get 107 153rds. Now, that's one way of doing the problem, but I'm going to show you guys maybe a way that's slightly quicker. So, instead of doing all of that, of finding every single scenario where that happens, the probability that both batteries are different colors is the same thing as 1 minus the probability of matching color. You're taking out the complement from the total probability to figure out what's left over. So the probabilities where they match, that would be red, red, blue, blue, and orange, orange. So that is 1 take away the probability that they match. So the probability that they match is red, red, which is 5/18 times 4/17 plus blue, blue, which is 6/18 times 5/17 plus orange, orange, which is 7/18 times 6/17. And I believe when you grab a calculator and do that, you should get 107 153rds. So they match up. So sometimes you can save yourself some work by just doing 1 minus the complement. And that's what I want to say right here. That the probability of A is 1 minus the probability of A naught. Sometimes you can save yourself a lot of work just by finding all the situations where A is not happening and then subtract it out from 1. Last example, Mark buys his t-shirts from exactly 2 suppliers, 2AT and Netshirts, and he only buys 2 colors, gray and blue. It's so exciting. He buys 73% of his t-shirts from 2AT, so I already see that 73% is right here. Moreover, 16% of his 2AT shirts are gray, so from 2AT, 16% of the shirts there are gray. First is copy and complete the tree diagram. Well, first things first, all of these, like this and this, are complementary events, so they have to add up to 1. So if you take 0.73 off of 1, you get 0.27. Same thing with these 2 situations, that both of those have to add up to 1. So subtract 0.16 off of 1 and you get 0.84. Same thing with these 2 right here, that this would have to be 0.2 because they have to add up to 1. Part B, calculate the probability that the t-shirt randomly chosen by Mark one morning is gray. So the probability of a gray shirt. The problem with this is it could be a gray shirt from 2AT or it could be a gray shirt from Netshirts. So it's really the probability of gray from 2AT plus the probability of gray from Netshirts. So the probability of gray from 2AT would be this route right here, 2AT and then gray. So that will be 0.73 times 0.16. And then the route of Netshirts will be 0.27 times 0.8. So this will be 0.27 times 0.8. When you add those together, you should get 0.3328. Yeah, that's that part. Part C. Given that Mark chooses a gray t-shirt, determine the probability it was supplied by Netshirts. So this is the probability, it's like, here, how would we write it? It's the probability of getting a Netshirt given that the probability that it was gray. Now, last class I showed you guys a formula on the board for this when we did that table investigation, where the probability of A given B is the probability of their intersection. So we'll say Netshirts intersection with the gray shirt, so a gray and net shirt, divided by the probability of B, which is probability of gray. Now, we already found the probability of gray up here, so that's going to come into play. Like, that part is going to be this part of the denominator. So really, the top, we just need to figure out the probability of a gray shirt coming from a net shirt, from net shirts. So this will be 0.27 times 0.8 all over 0.3328, which is about 0.649. All right, you guys, that's all I have for you today. Come ask me questions during work time.